This is a video on partial differential equations. The question states, show that the function satisfies Laplace's equation del squared z over del x squared plus del squared z over del y squared is equal to 0. And we have z equals xy minus e to the x cosine of y. So let's first recall the notation. Del squared z over del x squared, that means the second partial derivative of z with respect to x. And del squared z over del y squared means the second partial derivative of z with respect to y. So to find the second partial derivatives, I need to first find the first partial derivatives. So let's find the partial derivative of z with respect to x. So that means we're treating y as a constant, and the derivative of x times a constant is just x. Cosine of y is a constant, and the derivative of e to the x times a constant is just e to the x times that constant. So we get that del z over del x, or the partial derivative of z with respect to x, is y minus e to the x times the cosine of y. Now let's find the second partial derivative of z with respect to x. So now I'm treating y as a constant again. Derivative of a constant is 0, and minus the derivative of e to the x times a constant is minus e to the x times that constant. So I get that the second partial derivative of z with respect to x is equal to negative e to the x cosine of y. So now let's find the second partial derivative of z with respect to y. So first I find the first partial derivative of z with respect to y. When we have xy, x is a constant for the first partial derivative of z with respect to y, and the derivative of a constant times y is the constant, or just x. And e to the x is treated as a constant, and the derivative of the cosine of y is negative the sine of y. We have a minus, negative is positive, so we're left with the derivative of z with respect to y is equal to x plus e to the x sine of y. So now let's take the second derivative of z with respect to y. Here x is a constant, so its derivative becomes 0, and the derivative of the sine of y is the cosine of y, and e to the x is a constant, so it stays. So I get that del squared z over del y squared is equal to e to the x cosine y. So now I just substitute. I have del squared z over del x squared is negative e to the x cosine y, plus del squared z over del y squared is e to the x cosine y. So I get negative e to the x cosine y plus e to the x cosine y. And if I add those together, I get 0. And that was my goal, was to show that the left-hand side of this partial differential equation is equal to 0. And I'm done with the problem.